And here we go. Factoring square roots coming to you from the bushes. Okay, here we go. Factoring square roots. All right, so you've got a non-perfect square root. Right, your perfect squares, things like 4, 9, 16, 25. Those are all perfect squares. So if you have a non-perfect square root where you try and find the square root of 12 or 32 or 68, 4 steps. Find the factors, and then pick the pair of factors that has a perfect square root. Split the square root into a product of square roots, and then simplify. So for example, we've got square root of 48. Right? Factors for 48 are going to be 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Okay, so what's our perfect square there? It's going to be 16. So we're going to use the factors 3 and 16. For step 3, split the square root into a product of square roots. So I get the square root of 3 times the square root of 16. Right, gives me a square root of 3 times 4. You can also put that as 4 square root 3. Here comes some kids. It's loud. Right, so here's some examples. Right, square root of 28. Right, step 1, what are the factors? 1 and 28, 2, 14, 4, and 7. They're going to gym. Right, so where's our perfect square? It's going to be 4, so we're going to use our factors 4 and 7. Right, so square root of 28, it's the square root of 4 times square root of 7. Square root of 4 is 2, so you end up with 2 square root 7. Right. Square root of 63, right? So find your factors. What have I got? 1 and 63, 3 and 21, 7 and 9. Which one's a perfect square? 9's a perfect square. So we're going to split it up into square root of 9 times the square root of 7. Square root of 9 is 3, so we end up with 3 square root 7. So square root of 72. All right, what's our factors? I've got 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Ooh, now this one's tricky because I've got 9 is a perfect square and so is 36. So whenever you have to pick, you want to pick the largest perfect square. That's why we're going to pick 2 and 36. All right, so break it up into a product of square roots. Square root of 36 times the square root of 2. Square root of 36 is 6, so we get 6 square root 2. Now your try. I'm going to give you square root of 96. This is where you pause the video. I'm not going to show you step by step after this either. Give it a pause. All right, unpause the video. You should get 4 square root 6. All right, next one to try, square root of 180. Pause your video. Unpause the video. You should have gotten 6 square root 5. Okay, so adding variables. We're going to do the exact same thing, same steps. You just have to do it separately for your coefficient and for your variables. So find your factors, pick the pair of factors as a perfect square root, split your square root into a product of square roots, and simplify. What have I got? Square root of 24x squared y to the third. Thorns on that. All right, so our factors, 2 and 12, 3 and 8, 4 and 6, those are the factors for my coefficient. Now my factors for my variables, I've got x and x, that makes x squared, and then x squared and y. Which one of these are all going to have a perfect square? I need to try and find one for my coefficient and for each variable. So 4 is a perfect square, x squared is a perfect square, and so is y squared. So I'm going to break those into a product of square roots. Square root of 4 times square root of 6 times square root of x squared times square root of y squared times square root of y. All my perfect squares, I can actually do the square root under, so I get 2 times square root of 6 times x times y times square root of y. Everything outside the radical I can combine, and then everything inside the radical I can combine. So I get a total of 2xy times the square root of 6y. Let's look at some examples. Right? Square root of x to the third, y to the fourth, z to the fifth. Okay, so what are going to be my factors? X squared and x, y squared and y squared, and then z to the fourth and z. Right? So highlight my perfect squares. Each factor, I didn't show you all the different ones this time. Split it up into a product of square roots. Square root of x squared times square root of x times square root of x to the fourth times square root of z to the fourth times square root of z. Anything that can be square rooted, we do. So I get x times square root of x times y squared times z squared times square root of z combine all my factors outside the radical and combine all the factors under the radical to get x y squared z squared square root xz. I've also got 16 x to the fourth y to the negative third. We didn't talk about negatives. It's okay, just follow the exact same routine. My factors for 16 are going to be 2 and 8, 4 and 4. And then x squared for my x to the fourth. And then y to the negative 2 and y to the negative 1. Going to be my factors for y to the negative 3. Okay? Pick which ones show me perfect squares. And we break it out into a product of square roots. Square root of 4 squared times x, square root of x to the fourth, times square root of y to the negative 2, times square root of y to the negative 1. Find the square roots of the things we can. So I get 4 times x squared times y to the negative 1 times square root of y to the negative 1. Combine terms outside the radical, combine terms under the radical to get 4x squared y to the negative 1 times square root of y to the negative 1. Here, you give it a try. This is where you pause the video. Square root of 32a cubed b to the fourth. Give it a moment. Pause the video. And here's your answer. You should have gotten 4ab squared times square root of 2a. Here's another one. Square root of 18c to the negative 2d to the fifth. Pause your video. Should have gotten 3c to the negative 1d squared times square root of 2d. All right, moving on. Decimals and fractions. Well, anytime we have a decimal or a fraction under the radical, the square root answer is larger than what you're seeing under the radical. For example, square root of 0.04 is 0.2 times 0.2. Right, so the square root of 0.04 is 0.2. Square root of 0.25 is the product of 0.5 and 0.5, right? Which means the square root of 1/4 is actually 1/2. And if I have 0.81 under the radical, that's a product of 0.9 and 0.9, which means the square root of 81 hundredths is 9/10. We can see the same thing with fractions, right? So the square root of 1/9 is the product of 1/3 and 1/3. So the square root of 1/9 is 1/3. Square root of 1/36th. 1/36th is the product of 1/6 and 1/6. So the square root of 1/36th is 1/6. And 1/144th is the product of 1/12 and 1/12, meaning that square root of 1/144th is 1/12. Okay, you only need to be able to do perfect square decimals and fractions. You're not going to have to be able to factor your decimals or your fractions under a radical. Just letting you know ahead of time. Check the tests and everything. Factoring square root summary. Here we go. Follow these 4 steps. Find the factors. Pick the pair of factors that has a perfect square. If there's more than one set of factors that has perfect square, pick the one with the largest perfect square. Split the square root into a product of square roots. Simplify. All right, here's a couple of tips real quick. If there are multiple factors with perfect squares, pick the largest perfect square. Right? Otherwise, you're going to have to go through the process twice to find the simplest answer. Negative exponents work the same as positive exponents under the radical. Don't stress out about flipping it or trying to turn it into a fraction. Just follow the rules to find the square root and you'll be just fine. And lastly, fractions and decimals less than 1 will have square roots that are larger than what you see under the radical. Thank you very much. Don't forget to like and subscribe. Right? Comments in the comment bar. And we're going to call it down that video.